For the next phase in this build, I want to assemble these two differentials into parts of the suspension. According to this drawing, I will build two of those, and they need several parts, a number of wishbones, 4 per axle. Here I've got some universal ball joints, plastic ones, and they need to be added to all those black wishbone pieces. Until the end, every black piece has this hole. There's a hex cut at the bottom of it to house that hex stud at the end here. And the way this goes together is that the ball joint is in a vertical orientation at the top and in a horizontal orientation at the bottom there. And with this being a bottom piece of the bottom wishbone, this ball joint goes in horizontally like so, with that small flange pointing upward. And to secure it in place, there's this small hole right here, and that'll take a small M3 bolt. So this bolt goes in here. Now it's a case of just screwing this in tight enough. So that's for the bottom piece. The top wishbone has these extra tabs on the top. This ball joint goes in with a vertical orientation and a small brass flange pointing towards the back of the vehicle. That would mean that this goes into here something like this, and then I'll fix it in place with an identical bolt. Okay, that's tight. So that's number 2. I'll do the rest of these wishbones, and when that's done I'll be back. So that's finished. They're all in there pretty tight. Next up are a bunch of different ball joints. These ones, which connect the wishbones to the differential. And I need 8 for every differential, so 16 in total. And this should cover that. They come pre-threaded, but these are not the best quality. I hope they're all usable. We'll see. I have a second drawing laying out all the exact dimensions of these wishbones. So the dimensions for all the back-facing wishbones are these, and these point toward the front of the vehicle. So that means, for instance, for this wishbone, it needs to be screwed on until there's exactly a distance of 64.8 between this black piece and that small counter nut right there. So that's the next thing up. And when I'm ready, I'll be back. I have now decoupled these two differentials, like so. So this differential would go in between these parts like so. And these go on the top. And to fix everything in place, I'm going to need a bunch of these. I'm going to put this on its side, take a bolt, put it through here, then add this small washer. Okay, let's turn this around, and then okay, let's add this one on this side, same recipe. Okay. Okay. This one goes on like so. I think you got the idea. I'll screw this in place, and when that's done, I'll be back. The next thing to add to the differentials, these two vertical mounting plates. These, yeah. And as always, I'm threading directly into the PLA. Paper is still on here. Yeah, I'm gonna clean this off and mount these plates, and then I'll be back once that's done. I mounted all the mounting plates, they're in place now, but upon checking turned out that I mounted all 4 of these ball joints in the wrong orientation. It took me half an hour, but they're in the right orientation now, so now I can add the wheel hubs, and they will have to come off again later. The way this goes together is pretty easy. And the same type of bolt goes in the bottom ball joint and then into that bottom hole right there. Let's put this on its side. Well, as you can see, there's steering. Of course, I should have added all the wheel bearings beforehand. This is the smaller outer bearing. It goes in like so. And on the inside is a bigger bearing, and that goes in like so. These 2 hubs have their bearings in place. The other 2 hubs I'm going to remove now and press the bearings in place. Okay, 2 more outer bearings. This is not good, and this one, it's a bit loose, but it's okay. This press fit into place very well. This was okay. This bearing into here is far too loose. It just falls out. I'm reprinting this one, and when that's done I can continue with building. One very fiddly aspect of this entire build is assembling a drive shaft like this into its proper location. I'll try and show how I do that. It basically consists of the following parts: this outer cup, one such ball cage, then the drive shaft with both its inner members, and the same on the outside, ball cage and a constant velocity joint cup, and a number of small steel balls. When they come out of this bottle, they're not exactly clean, and that's about 12. That should be enough. Cleaning these is simple but very fiddly because they're small. I just roll them between 2 pieces of paper. Here you can see on camera the discoloration right there. I think it's a bit of grease and maybe a bit of oxidation. I think these are clean enough to be used right now. At least they're shiny. Now comes the tricky part. I never did this with these rubber boots in place. Let's try this anyway. First, a bolt cage goes on. That's a very tight fit, and I need to make sure that the bolt cage does not break. And there it is. And now both these parts need to go inside this cup. So it's in, as you can tell. The next trick is to line up the 2 ball grooves along with one opening in the ball cage. Something like this. I hope the camera picks this up, but there's a ball groove right there, there's a ball groove right here, and there's an opening right there. So now I take one ball and I just push it in there. Now very carefully I turn it 60 degrees about. Make sure that the ball cage is in place and has the correct angle. Now I take the second ball and then I just push it in deep into that groove. And again, ball number 3. And it is in. Okay. Number 4. Okay, let's see if the next ball will fit. No, it won't. Okay, like I said, it's always very fiddly. Now it's in. Okay. It's all very tight. It's creaking and making all kinds of noises, but I still need to get one more ball into there. You heard it, it's in now. So this is one assembled constant velocity joint. I need to add lots of grease and then the boot can go on. For now I'll leave this open and I'll turn my attention to the wheel side. This is going to be really awkward. Same goes for this side. On goes the ball cage. Here's the wheel drive shaft. That goes on next. Like so. And again I need to line up this ball groove with that ball groove and at the same time with one of those openings in the cage. The first ball is always the easiest. There it is. 60 degrees turn. All while maintaining the correct angle of the ball cage. Click, click, 2 more to go. This is number 5. Click. It's very tight right now. Well, if I break a ball cage, I'll have to print a new one, and I don't want to do that. So there it is. Okay, now very carefully. This all feels very tight, but it's in place. But basically, I have one assembled drive shaft right here. Pretty sure I have grease here somewhere. This is just a basic multi-purpose grease, which will work fine for this purpose. This is my grease application apparatus. And here's a glob of grease. Okay, let's see if that helps any. Oh, it's still very hard to turn. Nothing broken so far. I'll let this one rest for a bit and turn my attention to this one. This one needs grease as well. Well, this inner one seems a bit more cooperative, but the ball cage seems to be stuck in place. Why? This ball cage already cracked, so that one I will need to replace, which is a bit shit because I greased it up already. Okay, end result is the ball cage in this CV joint has cracked, so I'll have to replace that one. This one seems okay, but it is still very rough. I'm going to fiddle some more with these, and I still need to reprint one of these wheel hubs. So when that's all done, I will be back.